Hello and welcome to another episode of the Blockbusters and Algorithm podcast. The last time we spoke, we talked about the movie M3GAN, comparing fictional AI in the movie to real-world AI, where we made mention of the A17 bionic fusion chip. On this episode, we're talking about the technical aspects of M3GAN's AI, exploring its components and how it interacts with its environment. So we're covering a breakdown of M3GAN's AI as depicted in the movie. We will explore how AI learns, evolves, and interacts with its environment. Also discussing technical aspects of M3GAN's AI, drawing parallels with existing AI concepts and terminology. So let's dive right into it. First thing, breaking down the components of M3GAN's AI as depicted in the movie. M3GAN is said to have great listening skills, recording conversations with Caddy, and one time replaying a story that Caddy told her that was emotional for her as a means of recording that memory. She can simulate different voices, a feature that she uses when reading stories to Caddy. To achieve listening in most AI systems, machine learning techniques like automatic speech recognition (ASR), automatic speech recognition (ASR), and natural language processing (NLP) are typically employed. Now let me explain how this works. Now ASR, automatic speech recognition, takes the audio and converts it into text, and then NLP, natural language processing, is applied to the text, processing it to derive meaning. This is typically how your devices work. You say something to Siri, you say something to Google Assistant, ASR takes that audio and turns it to text, and then NLP is applied to the text to derive meaning, and then can then act. Maybe you're telling your phone, play me a Drake song, or what's the time today. This is basically it is ASR and NLP working together in that moment. Now this happens in real time. This happens in real time in M3GAN or your everyday voice assistants like Siri or Alexa. Now, you might have noted that sometimes your voice assistant gets instructions wrong, like it didn't hear what you said properly. Sometimes you say something that has maybe I tell Siri to play me a song like Erogo by Tokwe Alabi. Now, if it wasn't built on a data set that has Yoruba as a part of it, its ASR is definitely going to misinterpret what I said, and then whatever NLP tries to interpret in that context is definitely going to be wrong, and definitely it's not going to play the right song. It likely might not play the right song. This is what happens where the ASR system does not properly implement what you said into text for NLP to implement. Now for the speech aspect, ASR is still relevant, but in tandem. Now so far we've spoken about translating from voice to text for interpretation. Now for speech too, for its system to speak to you, for an AI system to be able to talk in that sense, ASR, automatic speech recognition, is still relevant, but in tandem with text-to-speech or TTS techniques. Now, I said earlier that a typical AI system will take the audio, uses ASR to convert it to text, and then apply NLP to derive meaning and implement action where this is the case. Typically how it works. But if you want your voice assistant to tell you a joke, or if M3GAN was to tell Caddy a story, the NLP component would carry out a search, ranking for key terms in your query, carrying out autocorrect in the event that the ASR might have misspelled something, carrying out a search in the query in order to derive a machine-readable translation. Now, the NLP cannot understand word for word what you're saying, but it ranks the key terms in what was translated to it by the ASR. So the key terms in, let's just say, tell me a Seinfeld joke. The key terms there, joke, Seinfeld. But in the event there was maybe a mistake, maybe in the spelling in the translation that ASR provided, NLP will then apply autocorrect there. And then after it does that, it then carries out a search for that query, Seinfeld joke. And then after that, in order to then derive, like I said, a machine-readable translation. Now, store this translation back into speech for you. TTS comes to play. TTS means text to speech. A text process is first processed. I know that sounds a bit clunky, but and then a voice, pitch, and duration are predicted. So it has gotten the Seinfeld joke for me that's going to tell me. Then is to apply a certain voice for saying that a certain pitch to get the joke right. And then this process here is a whole lot more complex than I can really explain in this play. But broadly, this is how M3GAN or any other voice assistant or any other AI tool that you can speak to and it can provide responses to you will essentially work. A combination of ASR, NLP, TTS, really. Now, with that said, let's explore how AI generally learns, evolves, and interacts with the environment using M3GAN as an example. Now, M3GAN has real-time access to the internet and as such is able to provide accurate responses to factual questions. One way to achieve this in an AI system is by web scraping, using softwares like Apify, Octopus, PassHub, Scraping Dog, just mention a few. These basically are used to extract data from websites. So we can assume that M3GAN is either encoded with one of these softwares or a custom built scraping functionality was installed into M3GAN. Early on in the movie, we also told that M3GAN never runs out of patience when reminding Khalid to flush the toilet and wash her hands, because we mentioned before that M3GAN becomes like a support system or like a co-parent, like a child care assistant for Khalid. But towards the end of the movie, M3GAN's psychotic bent indicates a radical shift in what should ordinarily have been an empty emotional slate. How do you go from being a patient, or would I say long-suffering robot, to being a maniac? Now, conventional wisdoms inform that AI systems are incapable of emotions, and whatever emotional reaction they project is based on programming. For an AI system to achieve parity with humans in terms of emotional capacity, it would have to replicate the subjectivity of human emotions, understanding emotions and their context. Currently, this is beyond our capacity, as it will require a complete replication of the human brain, especially the limbic system, which controls emotions. The limbic system covers stuff like the amygdala, which simulates our fight or flight response whenever we feel threatened. The hypothalamus, which controls our emotional responses to events and sexual responses when aroused. The hippocampus, that preserves and retrieves memories, or the limbic cortex, which contributes to happiness response. So you have to replicate all these parts of the brain: hippocampus, amygdala, limbic system, all of these in order to develop an AI system that can match the average human, even a 5-year-old or a 6-year-old child, in terms of the range of human emotions. Emotional reaction in any real-world AI system that you might have interacted with is really limited to interpreting our emotions based on cues, as opposed to having genuine empathy or understanding of what you are going through as a human being. So take for instance now, I could be really happy right now, but if I can suppress it by holding back my smile and walking really stiffly or walking really slowly, and I've not done that before, but if I could do that, if I could really suppress my happiness, or really feeling happy and really suppressed it, a facial recognition system trying to detect my emotional state on the basis of my face would deliver a false result. Many of us have done that before, let's be frank. You feel happy, but you just keep a straight face. Someone looking at you feel like, oh well, he's just mellow, he's just cool. They will know that you are literally jumping for joy inside you. So a facial recognition, so even if a human being, could look at you and not detect your emotional state from your face because you're hiding your joy, you're hiding your sadness, whatever it might be, how much more a system that is trained to detect emotion based on facial cues? Now, this is one of the criticisms of facial recognition systems, honestly, in the real world, because the human face has a wide range of variability in terms of shape, size, appearance, and even with the use of makeup. In the absence of real emotion AI that can match human capacity, emotion AI via facial recognition as we have today is really a poor knockoff, to be frank. Next thing, let's discuss the technical aspects of M3GAN's AI, drawing parallels with existing AI concepts and technologies. A key aspect in M3GAN's operations is the lack of parental controls initially and the use of voice command to encode this while she's already deployed in the real world. So they developed these robots, they did not take the time to introduce parental controls and just pushed her into the real world, and were only trying to introduce these parental controls in a haphazard manner when she was already interacting with the real world environment and learning the real world. Now, one time at the lab, Gemma and her colleagues are talking about the risk of allowing a robot to take the place of parental guidance, something I will discuss in the course of this episode. And they raised the issue of death in relation to Caddy's parents, M3GAN, who all this while was in the lab with them, and they thought she was turned off, suddenly asked, how did Caddy's parents die? Gemma instructs her to turn off, but she doesn't do so. Instead, she goes online and starts reeling out information about the death of Caddy's parents. Previously we talked about how an AI system can convert text into speech. So it goes online, uses web scraping like Parsing Hub to get information of the website, uses NLP to understand the queries there, and then converts that to a machine readable translation, and then selects a voice speech and then reads out what is on the website. That's basically what M3GAN did in that part there, looking for a website that reported Caddy's parents' death and then read that out. All this happened real time. The team at the lab, Gemma and her colleagues, realized that, M3GAN's inability to respond to the kill switch or to the off instruction is due to the fact that she has only one recognized user, Caddy. So if Caddy is not the one telling her to turn off, she will not turn off. And Caddy is a minor, so it will. I've heard that there is a sequel for M3GAN coming up I think it should be out in 2025. I really hope that that sequel explores these serious gaps in issues around parental control and releasing a highly advanced robot and that can only be controlled by a minor. These are things that I feel like are serious gaps that really should be explored in part 2 of the movie. And Gemma instructs M3GAN to engage with the protocol for data requests. In other words, she wants her, before going online to get any information, to be cleared by her user. And M3GAN responds that, I don't have a framework for engaging Caddy on the subject of death. Again, M3GAN goes online. So you mentioned death to her. She goes online to understand what is death. So basically she learns that, death means the end of life. And then she then asks if she is also at risk of death. Now, rather than give her a response, because how do you explain to a robot that, you can't actually die, but it's possible to decommission you? That'll be another rabbit hole. That'll be another whole entire rabbit hole, okay? So rather than explain that to her, Gemma just avoids the entire topic and provides a modified goal for M3GAN. That her goal is to protect Caddy from harm, both physical and emotional. This is literally her words from the movie. To protect Caddy from harm, both physical and emotional. I dare say that this is the turning point in the movie, because you give a robot, highly advanced as M3GAN, the instruction of protecting her primary user from any form of harm, physical and emotional. You've literally opened Pandora's box in this context for her to interpret any action or inaction as something that could be harmful to our primary user emotionally or physically. There are definitely ethical and child safety issues to unpack from this scene, but our focus right now is the technical aspect covering kill switch and user control. Starting with the kill switch, we see that Gemma is unable to use voice command to turn M3GAN off because she is not a recognized user. Generally, this sounds like a sensible feature in some instances. Google Assistant on my phone will only respond to my voice when I say, "Hey Google." Somebody else, you have to say, that same phrase, "Hey Google," in the vicinity of my phone, there'll be no reaction. And I've tested this. I've tested this before. In that context, I am its primary user. If you are using an Android phone, your device can probably recognize your voice, and you say, "Hey Google," it'll turn on. But if I were to speak in the vicinity of your device, it will not be activated because you are the primary user. So it makes sense in that kind of context. It is, how much damage could Google Assistant do, really, let's be frank, compared to M3GAN? So if it only responds to you, the user of the Android or the Android powered device, fair enough, that's good. But when we are dealing with an advanced autonomous agent like M3GAN, giving only one person or assigning only one person as his primary user, and that person being a minor, can be a recipe for that kind of technology to spiral out of control. Okay, now a real world example of the importance of the kill switch can be found in OpenAI. Okay, in the pre-ChatGPT days, now many of us don't even realize that OpenAI has been in the business long before the world even got to know of ChatGPT. They've been there for a long time, really. In the pre-ChatGPT era, OpenAI were working on training an AI system to generate helpful and uplifting responses, which was going well. During one of the code cleanups, one of the researchers involved in the project, by mistake, changed the reward mechanism of the AI system. So instead of it to aim to provide positive responses, the system was now geared towards providing hateful and sexually explicit responses. This change happened overnight, and it continued. It kept on spewing out sexual expletives until the system was halted. Imagine if nobody at OpenAI had the access to shut down the system. Maybe only one person could shut down the system. Or this system was already in the real world and only one person or nobody could do to shut it down. I mean, like I said, many of us did not know of OpenAI until ChatGPT came out. But in the pre-ChatGPT days, they had created a system that was really dangerous. But at least it was in-house. Unless there were several people who had access to shut it down when it went out of control. Imagine if they didn't have those kind of controls. This system jeered at hate, thrown into the real world, learning hateful content. Oh man, that's a vicious cycle that, let's not even imagine how crazy it will get. This scene in M3GAN is emblematic of everything wrong with the movie and the harms that we should seek to curb in AI development. On no occasion, really no occasion, should a minor be assigned as a primary user of an AI system, and proper sandbox testing should be implemented to ensure that such systems cannot override human oversight mechanisms and go rogue. Really. In the next episode, we are going to discuss the importance of human oversight and other ethical considerations regarding M3GAN. Thank you for tuning in, and ensure to subscribe, share this episode with any other person you know who's interested in AI and like sci-fi movies, probably like me, and see you next week, hopefully. Goodbye.